This is a full GCSE Paper 1 non-calculator used for the Year 10 PPE in 2023. Okay, this is a simple question about finding the lowest common multiple. With numbers like this, it doesn't take very long just to make two lists and look for the first common number that appears on both of them. So I'm just going to do the multiples of 20 and then the multiples of 35, and I'm looking for the first number that overlaps. You can probably see it's going to be 140, but I'll just show you the other list as well. 35, 70, 105 and 140. Okay, and there is the lowest common multiple there. Okay, you can do it by prime factorising each number and gathering together the prime factors, removing the duplicates and multiplying the rest together, but this is so quick, I would just do it that way in this case. Okay, a question about probability. We know that the sum of all the probabilities must add up to one whole one. So we start by recognising that 1 subtract 0.55 will give us the probability that has to be shared between the remaining two. So that equals 0.45. That has to be split in the ratio of 2 to 1, because it says the probability of picking a white disk is 2 times the probability of picking a yellow disk. So if I made that 2x and this x, then what I'm really saying is that 3x must be equal to 0.45. So if I call that 3x, then it means that x would be a third of that, which is 0.15. Okay, so you can see that that would be 0.15, and this would be twice that, which is 0.3. And just to confirm, all three, as you can see, would add up to one whole one. Okay, this question is about a linear or arithmetic sequence. That means it's going up in equal amounts each time. In this case, it's going up by 8. So the nth term rule is containing 8n. Okay, and all we need to do is find out what the 0th term would be. In other words, what would be the term before the 5, and that would be -3. Okay, so the general rule is 8n minus 3. Here we have a simple problem-solving question. We're given some information about the area of a piece of A4 paper, and we know that a square metre of that paper would weigh 80 grams. So therefore, the mass of one sheet of paper would be 80 times 1/16, okay, or simply 80 divided by 16, which would be 5 grams per sheet of paper. Okay, but we have a total of 320 sheets, so we simply need 320 times 5, and that will give us the mass of 320 sheets. Well, times it by 10 and halve it will give you 1600 grams. Okay, and I would leave it in grams because the question is in grams. You could write it as 1.6 kilograms, but no need. Here we have a simple question about expanding brackets and simplifying expressions. So we just do each bracket in turn first of all. So for 1 mark we would need to have expanded at least one of the brackets correctly. So we've got 5w plus 10 Okay, and then we've got plus 6w minus 3 from the second bracket. And then we just need to combine them, so we have 11w, and we also have 10 take away 3, which is 7. 10w plus 7. This one, it's a multiplication, so we just have to times the numbers together, the p's together, and the t's together. Well, we've got 24. We also have p times p cubed, which is p to the power 4, and we also have t squared, t to the 5, which is t to the power 7. And that's it. Here we have a question about standard form. So a number in standard form has a first part that is between 1 up to but not including 10. So this number is in standard form, and this is the multiplier, which effectively tells us how far to move, how many places to move the decimal point. So 10 to the power 6 is 1,000,000, so this has got to be changed into 4.72 million, okay, which is going to be 4,720,000. Okay, like that. And that is now as written as an ordinary number. In this case, we do the opposite. We have an ordinary number. We've got to write it in standard form. So it means it's got to begin with 2.3, because 2.3 lies between 1 and 10. So the point has effectively moved 3 places to the right. So we have to compensate by multiplying it by 10 to the power -3, and that's the answer. This third question here, third part, is asking us to show that that statement is true. So we need to put some working down. If you cube something like this, which is made of a product of 2 things, then you can cube each part, you see. So we've got 3 cubed, and we've also got 10 squared cubed, which is 10 to the power 6. Okay, now that is equivalent to 3 cubed is 27, so it's 27 million, okay? And what I now need to say is that that is greater than 20 million. Now it's obvious that it is, but we need to show the steps that we're taking, and that's what we're doing here. Okay. A question about ratio and proportion. This is the ratio of red, green and blue counters in bag A. Okay, so bag A, just write it here with a bit more space. We have 10, 9 and 6. Okay, now in bag B we've adjusted those ratios. There's 20% more of the red, so that becomes 12. 100% more. 100% of 9 is 9, so if you add that on you've got 18. And a third more blue, so a third of 6 is 2, you need to add that on, so there's 8 blue. So the ratio, it's not actually the numbers in the bags, these are just the proportions, okay? So we don't actually know the numbers in each bag, but that's what we need to work with. Now the bag that has the greater fraction of green is A or B. We've got to find out. Well, if we take A, the total fraction that's green in bag A is 9 out of, okay, because there's 9 green in proportion to the rest, out of the total of those, which is 25, okay? And for bag B, if you add up the total, it's 38, and you've got 18 out of 38. Okay, so they're the two fractions that you've got to compare. Now, the easiest way of doing that is to change the second one into 9/19, I think is what I would do. So I would say 18/38 equals 9/19, and 9/19 is greater than 9/25. You can see that because you have two equal numerators but different denominators. So therefore bag B has the greatest fraction. Okay, and that's the answer that I would highlight. Okay, this is an interesting little problem about perimeter lengths and, in fact, a couple of simultaneous equations. So what I'm going to do is, these four rectangles are identical, so I'm just going to say that they have, each one has a length of y and a width of x. Okay, and I'm going to notice that going downwards I've got two lots of y, this is also y here, plus an x. So I've got 2y plus x equals 24 using the measurement at the side. Okay, so 2y plus x equals 24. And going across from left to right, I can see that I've got two lots of y minus x, okay, is 16. So 2y minus x is 16. Now if I add those two equations together exactly as they are, I will eliminate x and get 4y equals 40. So therefore y equals 10. Okay, now if I substitute y equals 10 into here, 2 10s are 20, 20 plus x is 24. So I can immediately see that x must be 4. Okay, now I can go round and put the measurements in, because the perimeter is the total distance around the edge. So I'm going to put here that I've got a 10 there, another 10 there. Okay, I have a 10 here, a 10 here, a 10 here, and a 10 along here. Okay, now you need to be careful with these because these aren't complete. You see, this is a 4. This bit here is also a 4. Okay, I've got a 4 here and a 4 at the end of this block here. Now these little bits here are going to be 6 because they're made of 10 take away 4, so that's 6, and that little bit there is also 6. So that's from here to here is 6, you see, and from here to here is 6. So I've now just got to make sure I've taken into account every possible length, which I have, nothing's missing, as I go around the edge. So I've just got to add them together. So I've got 6 lots of 10. Okay, I've also got the 4 4s, and I've also got 2 6s. Okay, that should be a plus there. So that's a plus sign. If I combine those three together, that gives me 60, 76, 88 centimeters. Okay, and that is the perimeter of that shape. Okay, this question is about the exact values of certain angles. You're supposed to know the sine and cos of 60 and 30 and the tan as well. Now, okay, you just got to write it down just to show you how it comes about. So it's 1/2, and the way that we know that is we imagine an equilateral triangle of side length 2. Okay, so these sides are all 2. And what we do is we take the bottom side and we split it vertically down the middle. So we create a line of symmetry down the middle there. So each part of that base is 1. Let's just take this side. So that's 1 and that's 1. And we know, because it's an equilateral triangle, that that is 60 degrees. Okay, so we know that's 60 degrees, and we know that the cosine of an angle is the adjacent over the hypotenuse, and that's the answer. Adjacent is 1, hypotenuse is 2, so the cosine of 60 degrees is a half. Okay, and for this question, part B, it's kind of linked to this, but it's a different angle now. We know that the tan of x is 0.7. That means the opposite over the adjacent is 0.7. Well, there's the adjacent, so this is the opposite. I'm just going to call it, well, I won't call it x because they've used that for the angle. So I'll just call it d for distance. Okay, so I know that d over 20 equals the tan of x, which is 0.7. Okay, so d over 20 is 0.7. So therefore, to find the length d, I just need to multiply both sides by 20. Well, 20 times 0.7 is 14. So it's 14 centimeters. Okay, here we have a question about transformations. And we have to describe fully the single transformation that maps the big triangle A onto the other one, the smaller one B. Get them the right way round. Now we need to use one of 4 words: translation, reflection, rotation, or enlargement. Now, although it's getting smaller, this is actually called an enlargement, and we must begin by writing that word. So we use enlargement, okay, and then we need to say what the scale factor is. Okay, so there's 3 pieces of information here. Enlargement, the scale factor is what it's multiplied by to get it from that size to that size. And you'll notice that it's 3 across there and it's gone down to 1. It had a height of 6 squares, it's now got a height of 2. So it's 1/3 of the size. So the scale factor is 1/3. Okay, and the third piece of information is the center of enlargement. Now, if you can't see where that is, you can draw these, what we sometimes call ray lines, which are just faint lines that join corresponding corners together. Okay, so we'll just take that through there like that. Okay, and then we'll take one from, say, this bottom corner through here, and through here. And you can see they intersect at the same point, which is the point 1, 3. So we just need to conclude that with center of enlargement. It's called the center, okay, even though it's nothing to do with the center of anything. Center 1, 3. And that would get you both marks. Okay, if you've only got 2 of those pieces of information, you would get 1 mark. And if you've only got 1 of them, you would get no marks at all. Okay, this question is about estimating a square root. So we're looking at 2,400, and we're thinking about square numbers that we know which would be close to that. And the one we're looking for is 2,500, which has a square root of 50. And that's what we do for an estimate in this case. Okay, and then we have to state whether our answer to part A is an over or underestimate. Well, we know that we've had to round this up, so therefore 50 must be bigger than the true value of our square root of 2,400. So all I need to say is it's an overestimate. Okay, overestimate. And you don't have to write a lot here, but you just have to give a quick note to explain it. Overestimate, and the reason is since rounded up. Since I rounded up, or just since rounded up. And that's all you need to do. Okay. Okay, here's a question about the number of ways of doing something from a set of numbers. Remy says there are 25 ways of making a two-digit number from these, but actually it's only 20 ways. There are 5 ways of showing, of getting the first digit, because there's 5 to choose from. Once you've taken that, to get the second digit, you've only got 4 numbers left to choose from. So it's 5 times 4 equals 20, okay, which is not the same as 25. Now, what you have to do is you have to explain why. Well, the best way of explaining why something is wrong is to show how it's done correctly, which is what you've done there, and that will get you the mark. Okay. Okay, so we have a question here about a quadratic function that we have to plot on these axes here. But first of all, we need to complete this table, and it's a non-calculator paper, so we have to work them out one by one. So the function that we are substituting into is 2 times x squared. So when x is -1, we're going to do 2 times -1 squared plus 4 times -1 plus 1. And if we work that out, we get, well, that's going to be 2, -4, which is -4, which is -2, plus 1, -1. Okay, when we put x to be 0, that's going to be 0, that's going to be 0, and it's going to leave with just 1. X is 1, that's been done for us. When x is 2, we just have to change the numbers inside the brackets to 2 and see what that would give us. Well, 2 times 2 squared is 8, 4 times 2 is also 8, that's 16, 17. Okay, so we would take those points and plot them. So we would plot -3 and 7 with a little cross like that. Then we would plot -2 and 1 with a little cross. And we would plot -1, -1, which is down here. And then we would plot the next one we would plot would be 0, 1, which is here. And then we would go up to do 1, 7, and so on. And you can see the symmetry of the quadratic curve that we're starting to see. Okay, then we would draw them together with a freehand curve as smoothly as possible. Okay, now it's much easier to do that on a pencil, with a pencil and paper, than it is on this tablet thing. So I'm going to take this out the way because I've already done one. This is a 6-mark question. So I'm going to take that out the way. I'm just going to clear this stuff here, and then I'm going to bring in this pre-drawn one, which will look very similar to what the graph would look like if you drew it perfectly. Okay, so that's the graph that comes from these numbers here, and these numbers were, there they are. Okay, so that's done. Now we're going to do the part C, use your graph to find estimates for the solution to that. Now what we have to do here, okay, is to make the function on the left look like this. So I'm going to write it as 2x squared plus 4x plus 1, okay, but to change that -3 to +1, I've had to add 4. Okay, so I must add 4 to the other side to get 5. Okay, so I've just basically added 4 to both sides of that equation. Now, to solve the equation using this information here, I've already plotted the graph of 2x squared plus 4x plus 1. So now if I also plot the graph of y equals 5, then where those two lines intersect will be the solutions. So I'm going to draw the line y equals 5 onto the same graph, onto the same axes, like that. And then I can read off estimates for my two values of x where they intersect. So that one there looks to be about negative 2.75. Okay, so negative 2.75. And the other one looks to be about 0.75. That's that one there. Okay, and they're estimates of the solutions from the graph. Okay, it's not requiring you to work out the actual solutions, just estimates. Okay, this is a question about division of algebraic fractions. So the first thing to remember is when we divide by a fraction, we multiply by its reciprocal. So I'm going to write this as p over p minus 7. Okay, and I'm going to multiply it by p squared minus 49 over p squared. Okay, so I've effectively inverted the second fraction. And because it's a multiplication, we don't need to put anything there. I've just put a little dot, and that's over p squared. Now we do some cancelling, but before we do that, we need to recognize that this is the difference of two squares. So we have on the numerator, if we combine everything, we've got p, and we also have p plus 7 times p minus 7. Okay, and on the denominator we have our p squared and p minus 7. Okay, I'll put them in the same order they are there, p minus 7 and p squared. Okay, so we now just do some cancelling out, and the best way to do this is to cross it out lightly and show that you're doing so. So we've taken out a p minus 7, and we can turn the p into a 1 and the p squared into a p, and that leaves us now with just simply p plus 7 over p. Okay, p plus 7 over p, and that cancels to, or rather simplifies to, p over p plus 7 over p. Okay, so p over p plus 7 over p. And the reason we're writing it like that is we can write the p over p as 1. So that's equal to 1 plus 7 over p, which is in the form that the answer was required. So that's the answer to the question. Here's a question about direct proportionality. Y is directly proportional to x cubed. So we write that like this. Y is proportional to x cubed. We then write an equation of proportionality. So we change the proportional sign to an equals and introduce a constant of proportionality. We normally use the letter k. Okay, and we now solve that for k by substituting what we call the boundary conditions which we're given. So we know that when y is 108, that's equal to k times 3 cubed. Okay, 3 cubed is 27. So 108 is equal to k times 27, or 27k. Dividing both sides by 27 gives us k equal to 4. Now that we know that, we put it back into this equation here, and we have a formula for y equaling 4 times x cubed. Okay, so k is always the number 4. We finally use that with x being 5 to evaluate y. So y is 4 times 5 cubed. Okay, and 5 cubed is 125. 4 times 125 is 500. And that's it. In this question, we've got to prove, using algebra, that this recurring decimal can be written as the fraction 19/30. So this is what we do. We start with x equals 0.6333, and we show that the 3 recurs like that. And then we find 10x. We multiply both sides by 10. Okay, and that becomes 6.3333, and so on. And we keep going until we get 2 numbers where the decimal parts match exactly. Well, these are different, so we carry on. 100x. Okay, now 100x means we take the previous one here and times it by 10, so we get 63.333, and so on. Now you can see that the 2 decimal parts of these are the same. Okay, so what we do now is we subtract one from the other, and that will remove the decimal part. So 100x take away 10x is 90x. Okay, so I've taken the second one from the third one. So I must do the same here. 63.33 take away 6.33 is just 57. Okay, so if 90x is 57, then x must be 57 over 90. Okay, and if it's 57 over 90, it's divisible by 3, numerator and denominator, so it's 19 over 30, which is the answer given. Okay, but you'd had to prove it, so you had to show those steps. Okay, we have a question here about a quadratic sequence. We're given the second and third terms as numbers. We've got to find the fourth term, but before we can do that, we need to find the nth term rule. Now, when we're talking about the second term, we know that n is 2. And when we're talking about the third term, n is 3. Okay, so we're going to form a pair of simultaneous equations. So when n is 2, n squared is 4. Okay, so we've got 4a plus 2b, and we know that when n is 2, the sequence has a value of 26. And when n is 3, n squared is 9, so we have a times 9, or 9a. We have 3b, and that sums to give me 48. So we have 2 equations in a and b to solve. I'm going to call them equation 1 and equation 2. Okay, and I'm going to try and get the I'll get the second term, the b term, to be equal to 6 in both cases. So the first one, I need to multiply it by 3, equation 1 by 3, and that will give me 12a plus 6b. Okay, and that's equaling 3 times 26, which is 78. And the second term, the second equation rather, equation 2, I'm going to times that by 2, and that will give me 18a plus 6b, and that's going to equal 96. Now I'm just going to subtract the 2 equations from each other, so I'm going to end up with, well, equation 4, and that's equation 3. If I take them away in that order, okay, equation 4, take away equation 3, okay, so I'm subtracting, and that will eliminate the 6b term, you see. So I'll get 6a equals 18, and therefore a is equal to 3, and I can substitute 3 into the first one. So if I sub 3 into equation 1, that will give me 4 times 3 is 12 plus 2b equals 26, so 2b must be 14, so b must be 7. Okay, so I'm just going to highlight those two numbers, A and B, because I need those now to write the general rule. So the general rule is now going to be 3n squared plus 7n. Okay, now we've got that, we just need to find what the fourth term is. So we need 3 times 4 squared plus 7 times 4. Okay, well, 3 times 4 squared is 48 plus 28. That makes 76. And that's the answer to the question. Okay. Okay, a very simple probability question. We've got a fair ordinary dice. It's thrown x times. Okay, write down the expression in terms of x for the probability. It lands on 3 every time. Well, that's simply 1/6. Okay, that's the probability it lands on a 3, and you just simply raise that to the power of x. So the more times you throw it, the less likely it is to be to keep being a 3. Okay, that's it. Okay, this is a question about a histogram showing the weights of babies at birth. Now, we have to remember with a histogram that it's the area of the blocks that represent the frequencies, not the height of the vertical axis. So we have the frequency as the area. 12 babies weighed less than 2.5 kilograms. So that means this block here has an area of 12. Okay, and so to make an area of 12, it's a rectangle with a base of 1.5, so it must have had a height of 8 to make the area 12, you see. So if that's 8, this is 16, okay, and we could label the whole axis, but we don't need to because we're working with this bar here. You can work out by going up in 16s that this is 96 here. Okay, so you've now got your frequency density scale. Okay, so using that information, I've got to work out an estimate for the number of babies that weighed more than 3.75. Now 3.75 is halfway between 3.5 and 4, so it's here. I'm just going to draw a line to illustrate that. Okay, so what I'm interested in is the area to the right of that red line. Now this last block here has an area of 16. Okay, that's 1 times 16. But what we're interested in is the area to the right of this red line in here. Okay, now this tall block has an area of 96 times a half, which is 48, but I've got half of that, exactly half, because the red line's in the middle. So that area is half of 48, which is 24. Okay, so the total area is 24 plus 16, which is 40. So the answer to the question is 40. It now asks me to explain why it's only an estimate. Well, we're assuming that the weights of the babies in all of these groups are evenly distributed. So we have assumed that weights are evenly distributed. We can say that as a reason. Okay, now we could say in all of the groups, I suppose, but to address the question, we're interested in the group 3.5 to 4 kilograms. Okay, So assumed weights are evenly distributed in 3.5 to 4 kilogram group. And that will answer the question. Okay. Okay, we have an interesting problem solving question here where we have got to find the area of this triangle ABE, okay, which is this one from here down to here, here, and here. Now we're given some information in the question about the areas of other triangles in the diagram. We're told that this one here is 5 and this one here is 15. Okay, so looking at these two triangles here, we can see that they both have the same height, which I'm going to call h. And because this has a third of the area of this one, then it means that if the base of this one was, say, x, the base of this one would have to be 3x. Okay, which means the total length across the bottom of this must be 4x. So this is how it works, because we're dealing here with similar triangles. So if that's 4x across there, okay, this little triangle has a base of x, this is 4x. If this has a height of h, this must be 4h, because the triangles, the big one, the very big one, is similar to this little one here. Okay, so that means that the lengths on this one are 4 times bigger than the little one, therefore the area scale factor, so area scale factor is times 16. Okay, I'm just going to make a note of that there. So what I can say is that the area of triangle ACE, that's the largest triangle, is equal to 5 times 16, which is 80. Okay, but I've already got 2 areas I know, which I need to subtract from that to give me the yellow area. Okay, so the area that I need of triangle ABE is equal to 80, take away 5 and take away the 15, which of course is 60 centimeters squared. Okay, this is about surds, and the first part is rewriting root 800 as something root 2. Well, 800 is 400 times 2, so all I'm going to say is that root 400 times 2, okay, is the same as root 400 root 2, which is equal to 20 root 2. Okay, and that's it. So that's the answer to the first part. Now we come to this one, which needs rationalizing. So all we need to do is multiply it by 5 plus root 5 over 5 plus root 5. Okay, so you take what's called the conjugate and you just write it over itself, and that will cause the denominator to lose the irrational part, the square root part. So we just carry out that multiplication using FOIL on the numerator and the denominator. So on the numerator, that will give us, let's put the fraction line in. Okay, so we're going to have 1 times 5 is 5. Okay, we're going to have the inner part, which is going to be, or the outer part rather, which is 1 times root 5, we've also got 5 times root 5. It's the inner part, so it's 6 root 5. Okay, and the last part will give us root 5 times root 5, which is just 5. Okay, so that's the first bit done. That's 10 plus 6 root 5, and underneath we've got 25. Okay, the minus 5 root 5 and the plus 5 root 5 cancel out, so we've got 25 minus 5, which is 20. Okay, now we'll just tidy that up because there's some simplifying that can be done. So we've got 5 and 5 is 10, so we've got 10 plus 6 root 5 over 20. Okay, and there's a common factor of 2 in each term, so we divide by 2, numerator and denominator, to give us 5 plus 3 root 5 over 10. And that's it. Okay, can't be simplified any more than that. Okay, now here we have a problem about the rules of indices and powers, and it would be very easy to go wrong on this, so show all your working very clearly and do it a step at a time. So I'm going to start actually by writing the 16 as a power of 2 to the 4, and you'll see that that will make the problem a bit more straightforward. So I'm going to write 2 to the 4, okay, instead of 16, but leave everything else as it is for the moment. That's going to go to the power of 3/4, minus 3/4 rather, okay, and that whole thing is going to go to the power of minus 2. Okay, so I'm just going to put that there and put another bracket around that. Okay, now that looks a bit complicated, but you'll see in a moment that will simplify significantly. I've still got over here my 2 to the power of m, and I've got my 1 as well. Okay, now looking at this, when you multiply, we've got a power of 4, then that's the power of minus 3/4, and that's the power of minus 2. You can just simply multiply these together, okay? The 4's will cancel, so you're left with minus 3 times minus 2, which is 6. So this is actually 2 to the power of 6 times 2 to the power of m equals 1. Okay, now that actually makes it a lot easier, because to get 1, we've effectively got 2 to the power 0. Okay, so now all I have to say is, okay, what do I need to make m to make that equal to 2 to the power 0? Well, using the rules of indices, I add them together. 6 plus m would have to equal 0. Okay, so I can just say that, can't I? 6 plus m equals 0. Okay, so therefore m must be minus 6. Okay, there are lots of ways you could approach that problem, but that is one way which I would use in this case. Okay, this is an interesting problem involving algebraic fractions, lots of algebra generally, and a good understanding of probability. So let's make a start. We've got to work out the total number of people in the room as a number from the information given here. So I'm just going to make a note that the total number of people in the room, because we're going to need that later, is going to be equal to all of these added together. Okay, so if you add those 4 terms together, you get 8x plus 1. Okay, so that's what we're going to be using later on. Now, we're told that 2 children are picked at random. Now, the total number of children in the room is going to be 3x plus 2 plus x. It's all of those in this ring here. Okay, so I'm just going to write that as the denominator of a fraction. Okay, because we're dealing with probability. And out of those 4x plus 2 children in the room, we know one of them was picked. We know that the probability they had glasses would have been x over 4x plus 2. Okay, and then we're going to pick a second child from the room, and we know there's now going to be one less wearing glasses, and there's going to be one less children in the room, so it's going to be 4x plus 1. And we know that the product of those two fractions is 2 over 51. Okay, so we're now going to cross multiply and write down some algebra to solve to find x. Now, if we cross multiply that, we will get 51 times x minus 1, and that will be equal to 2 lots of 4x plus 2 times 4x plus 1. Okay, we just need to start expanding out and simplifying. There's quite a lot to do here. So we've got 51x squared minus 51x. Okay, and that's going to equal, now I'm going to leave the 2 and I'm going to multiply out these brackets here to give me 16x squared. Okay, using the outer and inner term, I'm going to get 4x plus 8x, which is 12x. And I've got 2 times 1 is 2. Okay, so that's now got to be multiplied out to give me 51x squared minus 51x equals 32x squared plus 24x, okay, plus 4. Move everything to one side because it's a quadratic I'm going to be getting, giving me 19x squared. If I take away the 32x squared, I'm taking away 24 from minus 51, okay, and that's going to make minus 75x, okay, and then I'm going to take away 4 equals 0. Now it's a quadratic. It looks really difficult to solve, but actually it's not that difficult. And remember, this is a non-calculator question. So the only way I can get 19x squared, because 19 is a prime number, it's going to have to come from 19x and x. Okay? And there's only really two options for the minus 4. They're going to be a 4 and a 1 or a 2 and a 2. If you put a 4 there and a 1 there, you've just got to get the signs correct. Well, that's got to be a minus, okay, because 19 times minus 4 is minus 76, plus the 1 will give me minus 75. Now that gives me two solutions. X can either be the number negative 1/19, okay, or x can be the number plus 4. Now it's clear that one of those solutions wouldn't work, so what we can do is eliminate one of the solutions just by putting a cross there and a tick there, because x has to be a positive number and it has to be an integer. So now we know x is 4, we can finish the question off. And that means simply substituting in here. So the total is 8 times 4 plus 1. Okay, which is equal to 33 people in the room. And that's the answer. Okay, so a really difficult question, lots to do there, but a surprisingly straightforward solution if you get the quadratic correct. Okay, so you just be really careful with the signs and the processing of that. Okay. In this question, I am comparing the areas of circles C1 and C2. To do this, I'm going to compare the diameters, because if the diameter of one circle is bigger than another, then it follows that its area must also be bigger. So there are the two diameters. To find the lengths of those, I'm going to use Pythagoras' theorem. That's 10 and that's 10. Okay, that's 10 plus x, and this is 10 minus x. Okay, so I'm going to call this D1 for the diameter of circle 1 and D2 for the diameter of circle 2. D1 is going to be the square root of 10 squared plus 10 squared. Okay, which is going to be the square root of 200. That's the first diameter. Okay, root 200. Now the other diameter here is going to be D2, and that's going to be the square root of 10 plus x squared plus 10 minus x squared. Okay, if I work that out and expand each bracket out and simplify, I'll get this. I'll get the square root of 100 plus 20x plus x squared, and from the second bracket 100 minus 20x plus x squared. Okay, and that simplifies because you can cancel out the plus and minus 20x's. So that will just give me the square root of 200 plus 2x squared. Okay, so all I need to do now is a sensible comparison, and I'm going to say that from this information we've done, I'll put my conclusion over here. D2 rather, is greater than D1. Since root 200 plus 2x squared is greater than root 200. Okay, like that. So that's my statement, but just to finish that off, I need to say and x is between 0 and 10. That's given in the question, but I need to just include that really with my answer. Okay, because there are limits on what values x could take to make this statement true. And therefore, it's reasonable to conclude that area C2 is greater than area C1. And that would be the final step in answering that question. Okay,